Yeah, thank you, Richard, and Ree for inviting me for this talk. I really appreciate that. Um, yeah, today we are looking at harnessing large language models for qualitative research, enhancing methodologies through AI-driven analysis. Um, I don't need to introduce myself again. I've been introduced, so. All right, so the objective of today's when I say presentation is to provide an overview of AI branches, introduce large language models, explain weights and parameters in LLMs and their connection to prompt engineering, why qualitative research matters in education, why LLMs matter in qualitative research, and then introduce TAIWO framework, identify the key components of TAIWO framework, showcase some results that are as a result of applying TAIWO framework in research, in recent application. And then there will be room for question after that. So there are several branches of AI, but I'm just going to limit us to this. And majorly the focus of this this particular slide is just on the natural language processing. But however, we have machine learning, supervised and unsupervised learning, and reinforcement learning as they are under machine learning. We have natural language processing, text analysis, speech recognition, machine translation. We have computer vision, such as image recognition, object detection, scene understanding, autonomous vehicles under robotics and expert systems, decision support, and knowledge representation. However, our focus is on natural language processes since we are talking about LLM, and this LLM for qualitative research. So introducing large language models. So what do we need to know about large language models? LLMs use transformer architecture to process vast amounts of text data. They learn patterns and relationships between words and concepts. Unprecedented scale. It can be because of the capacities to process a large amount of data. It can be scaled. It has that capacity to be to scale. You can use large language model to process any large scale information, any large scale textual information. In that sense. So it enables complex language understanding and generation capabilities. And it contains billions of parameters. I will explain this in a bit in a subsequent slide. So foundation for applications. It forms for LLMs power chatbots, content creation, applications, research tools. They can summarize, translate, and analyze text. They can, and it's also evolving because we know that we can see the recent advancement in LLMs in reasoning, such as deep research and several versions of large language models. So I'm not going to spend much time on this to save time. So LLMs in language processing. LLMs represent the cutting edge of NLP technology. NLP, natural language processing, is like the traditional aspect of language processing. The automated aspect, the automated aspect LLM can be seen as the automated part of language processing. And we have already talked about understanding and generation. It can understand vast amounts of data and then generate vast amount of text in a short time. It's also, like I said, it's used to power several applications. It has transformational impact, which I will discuss in a bit. So let's keep going. Now I talked about parameters. So I want to explain them more because they are connected to our understanding how we can harness LLM for qualitative research. There are a lot of connections between in this large language model. It's a generative pre-trained transformer. There are connections in between which are called neural connections. And these connections are determined by the weights. The weights determine the connection strength between these neurons. And of course, they guide how LLMs interpret language patterns. And then there's what we call learning process, because this, like I said previously, these large language models can learn from or can understand large amounts of data. How do they learn? How do they do that? It is through the term called parameters. Parameters are numerical values adjusted during training. Models can contain billions of them across network layers. You hear of 51 billion parameters. Oh, Llama has these several billions of parameters. These are what help LLM to learn from learn from a large pool of data. And then for behavior of the model, we have what we call the terminology called weights and biases. This shape how LLMs process input data. They enable context understanding and response generation. Weights and biases, I will explain them in a bit. Let me not let the cat out of the bag yet. So we have prompt engineer. What's the role of prompt engineer in this process, in this sequence? Prompt engineering leverages existing parameters. It guides models without changing their internal weights. That is prompt. So I will explain that in a bit as well, because the core of this is the core of whatever we're doing is prompt engineering. So explaining the weights and parameters using real-world analogies. So for example, let's consider the case of a chef. So deep learning models work like chefs, perfecting recipes. They adjust ingredients, which are like the weights, and the cooking techniques, which are like the parameters, through practice. And that's what LLM does too. Is it can adjust the weights and the parameters over time, because it learns over time. So like I said, focusing on the weight, it determines the feature importance. Where should we place importance on? We have billions, we have several of these features in our large pool of data. What should we focus on? How should we focus on that? What should we focus on? That's the weight. Then the parameters talk about the techniques. And the parameters are fine-tuning settings. So like oven temperature, baking time, they help models adjust how decisions are made. How should we focus on this, on these parameters, on these weights? How should we focus on is the techniques? And these are learned over time. And then the learning process, models continuously refine weights and parameters. This mimics how chefs perfect recipes through repeated adjustments and feedback. So understanding this concept helps non-technical researchers grasp how LLMs learn from data to make increasingly accurate predictions over time. So prompt engineering is key in this at this point, and we are moving on to the next. How do we guide language models for whatever purpose we have? Excuse me, I think someone is trying to write on the screen and it's covering.
Yes, let me just you can continue. I will take care of it. Right.
All right. So guiding language models, or large language models is called large because it can process or understand large context. It can understand it can decipher from a very large pool of language. That's what it's called large language models. And then there are steps. And the prompt engineering shapes LLM behavior through carefully crafted instructions. Oftentimes when we chat with maybe ChatGPT and all that, we just, provide me this, or can you do this? Those are low level prompt engineering techniques. And those kind of prompt will not give you some relevant results, or they will give you results that you like, and that's why a lot of people are complaining. Oh, there are a lot of non-factual. LLMs hallucinate a lot because of the prompting scheme, because of the prompting that the type of prompt you provide or supply as input to the LLM will determine if your LLM will hallucinate, or what level or what measure of hallucination will be involved will be in your output. So now these are steps: context, craft clear instructions. Precise wording direct LLMs towards specific outputs. Clear prompts yield more relevant responses. Context setting. Provide background information. Providing background information frames the AI's understanding. Context guide interpretation of ambiguous queries. I have found this, and I have practiced this a lot, and I found this very, very true. When you provide good context for your LLM, you need not have, since I've been doing this about 2 years now, I've been having almost zero hallucination. So we have output formatting structure. So if you want the way you want your structure, or the way you want your output is determined from your prompt, from your input prompt. If your prompt is not well crafted, your output will also not be what you expect. And then so you need to also sometimes when you try certain input prompt, you need to go back again and refine it to be sure that it's giving you the right response. Your LLM is giving you the right response. Now, why qualitative research matters in education? I'm shifting from large language models and I'm transitioning us to now qualitative research, our purpose. Why does it matter? It's understanding context and motivation that's behind certain investigation is very crucial. Oftentimes it is numbers don't give us those contexts, so we tend to survey, interview, or whatever, and this could be we can be if you have students of 100 students or 50 students in your class, and you have to ask them to reflect on something. It's very important if you go through this reflection, you will get so many insights on how you can guide your students or whatever. If it's customer reviews, if you go through that, you will see so many complaints or so many positives that you can analyze and then bring out the things out of this text, and then provide you some guidance on what's next to do. So you can also from your analysis, you can identify unexpected patterns, right? And it also gives you when you get these things out of this text, you can easily inform better design. You can but what the current limitation of that is that it is time intensive, subjective, and limited in scale. You can't scale it to like, oh, I have 1,000. Want to reach out to 1,000 participants. That's qualitative research is very limited. Excuse me. And then, so why LLMs matter in qualitative research? Now, because of the time-intensive analysis of traditional qualitative research, LLM can process transcripts in minutes while maintaining rigor. So we can easily reduce time, through LLM. Researcher bias. We put when analyzing this, sometimes if care is not taken, the bias may be so strong that, or we may probably, let's take a case of a student, in a case of a class. You have bias towards certain students because they perform well. You may while analyzing their reflection, you may tend to favor them more compared to those who are not really doing well. But with LLM offers consistent application of coding frameworks across all reflections. So there's no fear of this bias. And then pattern recognition. LLM excel at identifying hidden relationships, reproducibility, because it doesn't have positionality, it doesn't have bias, you can easily reproduce the results. But for human, you can, even if I analyze a text or maybe a reflection 2 years ago, if I pick it up today, definitely I may not come up with the same thing, or my team might vary very significantly from what I did last time. So that is that doesn't really show us reproducibility. But for LLMs, whatever you get today, do that next time, you will get the same thing. So now introducing TAIWO framework. TAIWO is thematic analysis for interdisciplinary workflow operations. It's a theory-driven prompt engineering framework for leveraging and enhancing LLM's reasoning capability for thematic or qualitative analysis. So the TAIWO framework is an LLM-assisted thematic analysis. It's an AI-powered analysis, processes vast qualitative data sets rapidly. It identifies things humans often miss, and then it reduces bias because it's systematic, and it really generates great insights, which has been applied to has been applied to a data set that is currently under review. So we'll get to that in a bit. So the theoretical foundation of TAIWO. The first is that it is a structured. We start from 5 up. 5, 4, 3, 2, 1. So you start like that. Thematic analysis process, that is the core of TAIWO. I mean, it is the base. It represents the structured steps involved in thematic analysis guided by Brown and Clark 2006. So, and then after that, this structure is okay. It's just for Brown and Clark 2006, which you will see in a bit, is from familiarizing yourself with data, generating initial code, and so on. Now, to make this structure, so we also introduce prompt engineering techniques, where these are prompts designed to integrate each stage of TAP, that is the thematic analysis process, guiding LLMs to emulate the reasoning process of experienced human researchers. So, and this really integrating prompt engineering techniques, that is PETs, into the TAP state, into TAP, transforms TAP into thematic analysis reasoning mechanism. So we've called that thematic analysis is the reasoning layer in TAIWO that mimics human cognitive processing during qualitative analysis facilitated by PETs. So without PETs, TAM defaults to TAP. But with integration of TAP into TAP, with integration of PETs into TAP, we have TAM. And then the next layer is the LLM reasoning and operational mechanism. This is the neural architecture layer within which other components in TAIWO operate. It is the engine that powers TAIWO, and it's dependent on the model's reasoning performance, because LLM evolve, because it's evolving in performance. So the LLM ROM is is what determines the efficiency of TAIWO. So it sits the TAIWO frame. It sits TAIWO, all the other components of TAIWO. So, and then then we have the complete TAIWO framework, which will then. So we have thematic analysis process in TAIWO. It could have inductive thematic analysis or deductive thematic analysis. And so inductive is data familiarization, just following 6 steps, guided by Brown and Clark 2006. And then for deductive, you can integrate your research question, your existing theory framework or theory or framework, And then the initial code in the ITA becomes the initial code generation in ITA becomes deductive code generation in DTA, and so on. So yeah, we won't spend much time on that. So for prompt engineering, the role of PRET, that is prompt engineering techniques in TAIWO. So we have sequential prompts, which guides the LLM through the structured stages. We have the iterative prompts, which allows continuous refinement by the LLM itself, not just you, because it's an automated process. So it allows for continuous refinement by the LLM of of refinement of teams. Here in this case, you are refining the team, or you are refining the code that you are generating. Then we have the contextual prompt, which contextualize your research, your research question within the TAIWO framework, your framework within the TAIWO framework. And then, like I said, thematic analysis, reasoning, everything integrated into TAP forms the thematic analysis reasoning mechanism, which ensures human-like cognitive reasoning in team development. So here we have the thematic analysis reasoning mechanism. So we have first stage, step one is data familiarization. Step two, we have the initial code generation. Step three, we have team identification, and so on. So within this, you integrate your data sets, and then you can see some cyclical, some sequential, some shuffling. All of these boxes are the prompt engineering techniques integrated into the thematic analysis process. And the cyclic, if you see this, the one that looks like a circle, two arrows going around and around, is the cyclic reasoning process, showing that there is a reasoning in the that stage or that point is a reasoning process based on the prompts. The prompt is guiding the LLM to go in cyclic process while processing the data sets. Then yeah, and then we have the one that looks at an arrow going down is the acyclic or sequential reasoning process. Just moving from one stage to the other without going back. So just moving from one state to the other. And then we have the shuffling. So the LLM can shuffle the data sets to ensure complete and thorough analysis of your data sets so that no data is left untouched. So we have the LLM reasoning, like I said, is based on the neural architecture framework based on whatever LLM we are using. So right now TAIWO has only been tested on ChatGPT and Daily. We have not explored Gemini, Meta, and Cloudly. So and other LLMs. So in our subsequent study, we're going to be exploring all of this in a single study to see how TAIWO can perform across these models. So we have the TAIWO conceptual framework. Here we have the LLM realm, the PETs, which helps to interact with the, is the interactive. The PETs is that like I said, integrated into TAP to form TAM, and it's also helps the LLM to interact with TAIWO, and TAIWO interacting with LLM, and then the data set. So crafting the prompt around the structured process of TAP helps, it has been intrinsically integrated. We have intrinsically integrated several techniques to ensure that there is sufficient interaction to provide the relevant or adequate results that we are pushing for or that we are expecting. Now, in our recent application, we just want to give you the context of the data. We have the study participant from R1 University Engineering Faculty at an R1 University in the United States. Sorry, we have we analyzed 11 engineering faculty interview transcripts. So each of them were over 500 plus words. on faculty identity development as a case study, just because since the journal required that we have what do you call it? We have we should apply to a data set as a case study to see whether it can advance theory. We know TAIWO is a method, and we are laying claim that it's doing fantastically well. So how can we lay claim on the fact that it can extend theory? That was the reason why we applied it on faculty identity interviewing, faculty identity development transcript. And then we involved Eman. Eman analyzed, two Eman researchers analyzed using guided theory approach to thematic analysis, analyzed two randomly selected faculty identity interview transcripts. And then on the same transcript, TAIWO was applied. And then we crossed, there was comparison between human and TAIWO coding results, and the output was fantastic. So we then went further to apply TAIWO to the entire data set. So now they're showcasing the results. When we analyze the data, what do we find? I mean, how does TAIWO present the results? How can we trace, or what can we say of the result? So let's look at some examples of the analysis. But before then, these are steps to analyze your qualitative research with TAIWO, and upload or copy your transcript or whatever. It could be custom review, or it could be reflection into your LLM, or you can upload your PDF or LLM, your Word document into your LLM like ChatGPT, and then craft your directional prompt. This is to instruct. This helps to instruct the LLM on how to proceed with the analysis. Then apply TAIWO framework. So all of these are crafted into your chat box, and then once you click enter, step by step, we have several. We have step 1 to 6 in TAIWO. So you begin to copy the prompt for step 1 into your LLM, including your directional prompts, and then that will give you the result of the first stage, and then that goes on until the final stage, and then you look at the results. Does it make sense? How can you make sense of the result? So now data familiarity step 1. This is a result from step 1. It's just showing you summary of the data sets, giving you observations linked to research questions, and then gaps identified within your data. So this is just the summary of the results for step 1. If I'm too fast, you can call me back and ask me questions, or you can pause me and ask me questions on any aspect of this presentation. So looking at step 2, initial code generation, we see initial code integrity, identity integration. It's described and then it linked it to relevant research questions like, this identity integration is linked to research question 1 and 3. And then it brings out an excerpt of where it got that initial code. I feel like I've brought in all my personal self into how I behave professionally. So this excerpt helps you to track, helps you to provide a way to, which is what we do in qualitative analysis. Provide a way to trace, or a way to be able to check that if this is really true or not. And then with this, we can trace. You can go back to your data sets and see whether these codes or these excerpts are truly from that data set. So TAIWO framework constrains the LLM into your data set without, it doesn't allow any hallucination. So it does constrain your data and the LLM reasoning within your data. so that everything you get. And then, so this is table 1. We have 10 tables producing 100 initial codes. So that is how, I mean, you can produce more depending on how large your data is. So for step 3, we have team identification. And then we can see again, now the team, potential teams is identity integration, and then associated relevant initial codes, which is one of the things when you are combining team or when you are trying to identify teams, there are some codes that look similar, and then you group them to form a broader team. And this is what TAIWO is also doing here, is grouping this initial code, identity integration, identity overlap. Those are from the initial code generation, and then it groups them together to under the identity integration, and of course giving you some example excerpts. Oh, I feel like I brought this my passion. So these are 2 excerpts, relating to all of this, and then it gives you the shared meaning why those initial code go together. So this is yes, and then we have step 4, team review. So this is reviewing the team and condensing it to like 20 potential teams. And so we can also see that it's giving you connection to the research question, how that. So reviewing this team based on the context you provided. The problem context is not here, is the research question you provided you integrated into TAIWO. So with this, it's able to refine and review the team based on this context. If there are no context, it will review it the way it feels like, or based on the prompts in TAIWO framework. And then we have step 5. Now, team definition and naming. So this here, it will define that thing, or define the team that you have reviewed. It will define it and give you the significance of the team and the connection to research question. I mean, this there won't be step 6 here because that's an extensive discussion of your team and in connection to the literature and all that. So I won't be displaying step 6 here. But before I proceed, okay, let me just finish again. If I have anybody, if there's any question that you can ask. So in this, we discovered that human AI collaboration is very important in excuse me, in refining some of the things, because our faculty identity data is context specific, highly because the approach used by humans are grounded theory, and TAIWO approach is grounded in thematic analysis process. So analyzing the data from a different perspective, and that is thematic analysis, and from 2 different perspectives, it necessitates that there is need for human AI collaboration, even if both perspectives are the same. There's still need for human oversight. Let's check and be sure that the teams elicited from this from our data are consistent and are true, or are true representative of the data. And so we found this very crucial, very, very crucial in applying AI for qualitative research. And so here we went through this process. Human expertise is very needed. AI processing the pattern on scale. AI was able to give us very broad pattern, that human may not be able to produce. A lot of initial codes and all that. So review and refining. So with the result of LLM or the AI result can then be reviewed, refined, or validated to ensure that it's a true representation of your data. And then the insights can then be applied to whatever in your research and all that. So in future, so these are emerging capabilities we intend to, cross-language analysis. Can TAIWO be applied to? Can TAIWO be crafted in another language and applied to a data set in that language and still come up with the same thing? So that's some future direction. Multimodal integration. Multimodal has to do with source sources, different sources. Can we use TAIWO to analyze data from different sources, like image, like excuse me, like text, image, video. I mean, so those are. Then we want to based on this application, on this recent application to identity data sets, we can actually develop TAIWO or integrate something, integrates discipline specific framework into TAIWO to contextualize findings within that discipline. That way, it can be very beneficial for that discipline to use that. For example, we came up with TAIWO identity, and then the framework we use to analyze the framework of the identity data set, or the framework supplied by the human grounded theory researchers was integrated into TAIWO to actually completely contextualize all the findings. And that was why TAIWO was very successful in eliciting teams and expanding that framework. So that framework, that's TAIWO, that integration is there, and the framework can be used anytime to analyze any faculty identity data. And so that's what we are talking about. Discipline-specific versions of TAIWO can be a feature or our future directions. So we will continue to be more transparent in the methodology. Human oversight is very crucial, like I said, very, very crucial. And then the data set we used was de-identified to be sure that it was de-identified to be sure that we don't reveal any personal data data into the public or into the because this is going to be trained. Whatever you release into ChatGPT is going to be trained as a generic, and then anybody may have access to that. So we ensure that privacy was safeguarded. Apart from that, an IRB was approved for that data set. So, and then next step would be to develop a personalized interface for TAIWO, so that researchers with less technical expertise can take advantage of this, and develop an algorithm for TAIWO as well, so that we can begin to it can be integrated into any system. So you can just think about even Microsoft Copilot, or even ChatGPT itself. You can just say, I want to analyze this data using TAIWO. Or you can just go to some of the options in ChatGPT and say, hey, TAIWO, using TAIWO. So that's algorithm we enable that integration. And then we'll start with small projects to do when this is done. So here I come to the end of this presentation. So if you have any questions, comments, or feedback.
Thank you very much, TAIWO. Very interesting framework. I have some questions, but I'm wondering if anyone else wants to ask. Feel free to drop in the chat or just use the microphone. I'll wait a minute or so to see if anybody has any questions or comments. If not, I have some as well. I'm just looking through the chat to see if anybody has asked anything. Okay, so everybody just feel free to just barge in with your microphone or put something in the chat, and Rich and I will take a look. But I have a few questions, but I'll see what I can start with. So I'm interested to know a couple of things. Firstly, on a practical level, is there a source? What is the best source that you could recommend for us to learn more about this framework and how to apply this method? Or is that something that hasn't been fully published yet?
Yes, currently the publication is under review, and once that is available, I can send you the link, or I can,
So if you
yeah, I
could
can share
share,
that with you.
if you could share, I mean, if it's okay with you, if you could share the link, and then when we publish your video on YouTube, we'll put the link in the description, and then everyone can access. Of course, if
Yeah,
it's
sure.
not something you want, then don't share it. But I think for me, I'd like to study this more because there's a lot to it. Obviously, we're limited in the time that we have here. So I would really like to see some more information if there is available. The second question I have is about the human part or intervention. And maybe I didn't quite understand where the humans come in. I mean, I can sort of intuitively understand that it's a good idea to have oversight and it's a good idea to check things, but obviously part of the idea of using generative AI is to save time and to handle large amounts of data. So I'm assuming, some steps, the LLM technology is more reliable or as reliable as a human, and other steps, maybe we need to be more careful. So could you talk a little bit about where do humans come in this framework and maybe like the most important points where humans are involved? Because if you have an algorithm, right, that means you're just automating everything. Like, is that something in the foreseeable future, or will humans always be part of the loop?
Yeah, so for right now, because the framework is still based on prompt engineering, so you need to apply the framework systematically, step by step. Once you get the results, so you begin. So in your analysis, you check each, for example, the initial code generation. You can, because if you're using it for the first time, you need to check if it's really representative of what you are expecting. So if it's the case, then you move on to the next stage and generate the team. And then the next stage of reviewing the team, and then the next stage of defining and then naming the team. So, and then finally you report. The human will not always, for example, when we did this, because it's when we did this study, because it was, we are applying TAIWO for the first time for, to advance knowledge, to advance method, we needed to do reliability, inter coding reliability. So we needed to first randomly select two of these data sets, two of these transcripts, and then human coded separately, and then TAIWO was applied on the data sets coded separately. No human was involved in that case. But then the result of the two, then we came together, we analyzed the result, we checked the result to be sure that the result that AI is generating is close to what human has come up with. And then TAIWO did fantastically well, except for a few, because of the different approaches to analysis. So I said TAIWO did fantastically well. That was why we can be confident to say, okay, we need to move on with the analysis. So we applied TAIWO on the entire data sets. And when we did that, the result was also, we also came together to check and be sure that and then we refined some of them a little bit. But in between the steps within this framework, while doing the analysis, you don't need human to come in and check, except the analyst.
Okay, thank you. I know Ibukun put his or her hand up just before. Ibukun, would you like to add something or ask something?
Yes, I just want to add something. Great work, Taiwo. I'm actually with Taiwo with as regards research.
Mm-hmm.
And what I wanted to say, yes, said it. I think one of the first things we did before we allow Taiwo to complete the analysis of the work was we said, okay, about 1/5 of the transcript, Taiwo code, 1/5 of the transcript, human code. And then we came back to check. how accurate is the coding between the AI and the human, just to check that first test running of what is working well and things like that. So based on that, very similar, based on the outcomes, then we kind of moved on to the next step to check. The other thing that we also did was when the whole process of analysis was completed, we also went back and checked and said, okay, does this looks like what the data have said? Because everybody was familiar with the data we've read through. And
Right.
yes, that was done. Then the last one was, granted theory needs some, and just like other qualitative research needs some interpretive framework of extrapolating ideas. So that one too, human had to come in to like extrapolate the idea too in the context of what happened. So I see that until the time comes when we can fully make this AI, I would recommend that initially maybe 1 or 2 transcripts, both human and AI should code and look at it. And if there's some adjustment that needs to be made on both parts, and then we'll move on to the last final phase. And one of the things I also discovered during the analysis was the differences between the AI and the human coding was not necessarily a mistake. It's just like when 2 human coders also code articles, they would code sometimes a little differently, and then they resolve differently and move forward. I think that was more of what happened, as we coded the transcript.
Sorry, could you explain that last point? I didn't quite get that when you mentioned they would quote articles differently. You mean the reference that they provided, or I don't quite understand because I thought it was interviews, not articles.
Okay, so what I mean is this: let's assume we want to conduct a qualitative study, and there are like 2 researchers, researcher A and researcher B, code the transcript differently.
Yep.
Usually, most of the time, they will agree on the same coding, but there are few times where the way they coded differs, or somebody coded something the other person did not code, and then they have to meet together and then discuss, why did you code this way? Why did you code that way? What are the differences in the code, and what were you thinking when you were doing it? It's part of the norm of the qualitative study. So
I have just, sorry to interrupt, just because we have very little time. I think this is important to understand the claims that you're making. Your study that is now under review, is that inductive analysis, deductive thematic analysis, or are you looking at both? Because there's big differences, right, between the two in terms of like reliability and other things.
So yeah, we did all of the 3. In using TAIWO, we used deductive, inductive, and hybrid. And then it was, we had no challenge with hallucination, because I could see some questions here requiring the LLM. We have no challenge with hallucination at all. As a matter of fact, all the output wave, like I said, TAIWO framework restrains LLM to your data, and all your outputs are going to be within that framework. I mean, within your data. It's not going to hallucinate or going to formulate some things for you, no. And Dr. Abiku, thank you so much for chiming in. Dr. Abiku is an assistant professor in Penn State University.
Thank you for joining
so
us.
I collaborated with him on this, and then we did that. And then, he reviewed the output from the LLM, and he has no question, just like he explained. It's more or less like 2 researchers coding the same transcripts.
Yeah.
There's definitely going to be some differences in their coding. And then there's need for agreement, right? So in order to agree, you want to understand, why did you code this way? Why did you code that this way? And then from there, there can then be some adjustment to the code. So what LLM did was fantastic. The codes were no question that, if the code that came out where you don't have any question to raise, like, oh, this is completely out of, I mean, you don't have any of such fear, like, oh, no, this cannot be, no. So it's a matter of, okay, this seems to be different from what we have here. So how do we resolve this?
Last question from me, again, just to understand better what you did in your research. Which model, which LLM did you use? And did you use just one LLM or did you compare different ones?
So for currently, we just stayed with ChatGPT. And and then we access
one of the models of ChatGPT, right? Because ChatGPT is.
So we stayed with ChatGPT 4 and Delhi. They did, I don't know, Delhi, is it Delhi? I don't know how it's pronounced.
DALL-E is the image generator.
Yeah, so we stayed with DALL-E because it's more expressive. DALL-E is more expressive, and so
I don't think you mean DALL-E because DALL-E is a visual image generator, but that doesn't matter. I mean, it's one of the GPTs. That's all I
Yeah, it's one of the GPT, and it's doing fantastic work. It's one of the image generator, but I use it for a lot of qualitative.
I wonder, sorry to interrupt, but this is just an idea, and you can take it or not take it. I don't know what your opinion is. For inductive analysis, where you are not using grounded theory, right? You're asking the human or the LLM to identify themes. I wonder, despite the fact that you are limiting it to the transcripts, the model is still trained on other things. I wonder whether there will be a difference between, say, GPT-4, GPT-4o, and Gemini 2.5 and whatever. Like, if I were a reviewer of your paper, it's not a reason to reject the paper, but it's something that I would suggest for a future study, is to see specifically for inductive analysis where you have to look for themes, not based on a theory, because based on a theory, I can understand that it's very formalized and that you would come out probably with reliable results, I would assume. I wonder about the inductive analysis and looking for themes, not to say it's worse than a human, not saying that, but I'm just wondering if different models will come out with different things. And obviously you can run the model multiple times. It will probably find slightly different themes as well. That's at least from my experience. That doesn't mean there's anything wrong with it, but it does mean that, there could be differences between models. That's just a thought. It's not,
Yeah, we actually plan to do that for a future study. I mean, even, we have already planning on comparing results across different models and testing out on different GPT models. So we are looking at that, and then we are also open to collaborate. If you have, for example, if you have a large data set that we can use, so we are also open to collaboration where we can then test this out and see.
There are some things that I do that I think this could be very useful for. Of course, I would like to learn more. So anything you can share with us would be appreciated. We're out of time, unfortunately. I'm sure there's more questions and discussion, but this is good. It means there's more interest. Thank you so much, TAIWO, for your time, and Ibukun for joining us, and everyone else. As I said, this is recorded, so it's going to be put up on YouTube for everyone to see and share around. Thank you so much, TAIWO. And
thank you so much. Thank you so much, Ray, for having me. I really appreciate it. And I'm also hoping to, future presentation or demonstration of the framework, if that is available, if the option is.
Let me know when it's been accepted.
Yeah, sure. I will let you know.
Yeah. Bye, everybody. Take care.
Bye. Thank you so much. Yeah, bye.
Thank you, Risha.
Bye-bye.
Yeah.